I guess I should also do the thing that I'm required to do under federal ethics law, which is say that I'm, you know, expressing my own views, not the Navy's views or the government's views. So I'm just, an academic like everyone else. But I said that I was going to speak in embarrassingly concrete terms, but I can't help but sort of sneak a little bit of philosophy into anything that I do. So I tend to wrestle a lot with the term AI. If you say it, if you put it in the title of your talk, people attend, they listen, they pay attention to you. This is perhaps more true in the Department of Defense than it is even in the real world, although it's certainly very true in the real world as well. But the reason that I don't like the term AI is that it's hard for me to make it mean much of anything. So a common definition, a definition that you see, for example, in a lot of government strategy documents, is that AI is machine behavior that's intelligent. And of course, I think a lot of you probably know that this definition is a little bit problematic because we've taken the question of what is AI and we've hidden it in the question of what is intelligent. And to me, as an engineer, it seems like if a machine was behaving in a way that was unintelligent, we would say that machine is buggy and we should fix it or get rid of it. And similarly, this behavior has the, or this definition has the property that it means that AI kind of recedes into the mist as we make progress. An idea that's sometimes known as Tesla's theorem, which is that AI is whatever hasn't been done yet. That makes achieving AI a little bit like resolving Zeno's paradox, that in order to get to AI, we first have to get halfway to AI, so we can never get there. So instead, computer scientists often say that AI is a set of techniques, which is probably fine, but then we have to say, which techniques do we mean? Do we mean neural networks? Do we mean machine learning? Do we mean all of data science? Do we mean non-data science oriented techniques like classical AI or what people sometimes call good old-fashioned AI, rules engines? You have also the problem of arguments like the Chinese room argument by Cyril, and asking whether a sort of sufficiently robust database could be AI. There's an old joke in the system administration world that, if you go to your IT department, you might find someone with a mug or a t-shirt that says, "Go away before I replace you with a very small shell script." I think most of the time when people say AI, they don't mean shell scripts. So instead, I like to talk about automation. Automation has a very clear definition, which is that we take some task that used to be done by humans, and we situate that task in some artifact, in some piece of technology. And when we do that, we sort of inherently turn that task into a function which operates according to a set of rules. So what are rules? They're just desiderata that take fact patterns about the world and create outputs based on those, or decisions based on those facts, right? So, if the temperature is over a certain amount, open the window. If it's below a certain amount, turn on the furnace. And they're, by doing this, you sort of take interpretive space out of the problem being solved. You just kind of reduce it to perhaps a very complicated set of rules, perhaps one that's so complicated that it seems like what you are getting is approximates intelligence. And so one, I guess, kind of problem with eliminating AI as a term is that then you're sort of left with the people who believe that AI will take over the world, or that the singularity will come, or that the robots will come and take all of our jobs. And I'm here to tell you that the robot apocalypse has already happened. Now, it happened, but it didn't look like this. It looked instead like this, right? So what we've done is we've taken even basic tasks like moving freight around the world, and we've automated them. We've reduced them to the operation of a set of rules. And that set of rules can be quite complicated. It can be quite involved. It can build into huge systems. But those systems are efficient, more efficient than other systems that compete with them or that they competed with. And that's why they've taken over. And that's why it's sort of the robot apocalypse. So the other term that I think is a little bit challenging in the title of the talk is black box. So if you think about what a rule is, as I said, it takes a bunch of facts about the world, which we might call inputs, and it converts them in some way that we don't maybe see or understand to well-defined outputs. And we can repeat this over and over again. Which is the advantage of a rule, right? You can scale it up, you can run it really fast, you can embed it in little pieces of hardware that live all over your house, all over the world. But people often say the problem with AI systems, the problem with automated systems is that they're black boxes, by which they mean something like we can't see the rules or we can't understand the rules. And these are sort of two separate problems, right? One problem is often a problem of power asymmetry. We can't see the rules because Facebook or Google or the court system won't show us what the rules are. But at least they're rules. At least they're there somewhere, and we can reverse engineer them, or we can demand access to them and find them and verify that decisions we've seen are consistent with them. That's not true, for example, for decisions made by humans, where if you have a decision made by, say, a human judge, you probably can't take the judge's brain apart after the trial is over to figure out how that decision was made and whether you could repeat it if you created a similarly situated trial with some slight counterfactual variations. Another thing that people mean by these algorithms are black box is that they are, the rules are too complicated for us to make sense of them. So this is a picture of the architecture of something called AlexNet, which is a deep neural network with many thousands or millions of parameters, depending on exactly how you instantiate it. And the argument is maybe these parameters don't make sense on their own. Maybe they don't tell us anything about how the decision was made, but somehow there's too much complexity for us to boil that down into something we would call understanding. And I struggle with that as well, because it's still performing a deterministic calculation. It's just a very complicated deterministic calculation, and we perform all sorts of complicated analysis all the time. And it was a real honest-to-goodness philosopher, Helen Nissenbaum, who noted to me that I don't have to know how my refrigerator works well enough to design one or build one or even fix one to know that if I put my drink in there for an hour, when I take it out, it will be cold. And maybe that's what I care about. And so I often say that we get sort of wrapped around the axle maybe too much on this question of complexity and explanation and understanding, right? We don't ask a commercial pilot to explain the Navier-Stokes equations that govern the flow of air around the airplane. We just expect them to be able to fly the plane given the physics. And instead, we look for not just those selected explanations when we talk about how things work functionally, but also when we rebuild rebuild problems or failures after the fact. So the other use of black box that you come across in reality is the idea of black box as some kind of accident recorder, or some device that doesn't hide information from you, but actually tells you information in a survivable way, in an indestructible way. And so I believe it was the famous critical scholar Jay Seinfeld who argued that if the black box can survive the crash, maybe we should make the whole plane out of the black box. And for a plane that's hard, the black box is made of titanium. It's very expensive. It's very heavy. You couldn't really do that from an engineering perspective. But with software, you can probably get some kind of resolution of these two notions of what it means for things to be black box. So you can have something which does record what a system is doing and maybe does tell you that selected information that you need to know so that you can reconstruct its behavior subsequently. But I don't think that that's what other critical scholars have meant when they've used the term. So some of you may have seen Frank Pasquale's book, The Black Box Society, about these kind of power asymmetries that I was talking about before. Something that I'll note, which might be a bit of a left turn here, is when we think about automation as operating processes according to rules, one nice thing to me about that framing is that it abstracts the notion of what really matters about the operation of the system, that it is rule-based as opposed to being more interpretive, versus how that rule-based operation is implemented. So you could imagine rule-based implementation in terms of software or other computational artifacts, right? Data science models, formulas with thresholds, scoring systems that are used in the medical context. You could imagine mechanical rule-based systems like looms. You could imagine larger structures of human organized systems that operate according to rules. We tend to call those structures bureaucracies, just assemblages of humans and rules and bits of paperwork that make decisions, often critical decisions about people, in a way which is rule-based rather than interpretive, but in a way that we've also understood for a long time is maybe quite risky and problematic, or subject to needs for certain kinds of governance and oversight. Of course, today we're increasingly taking these buildings full of bureaucrats, and we are saving money by shrinking them down and putting them inside giant computer systems. And those computer systems cause a lot of consternation because people believe that there are harms that come from automation. I don't think I have to get too deep, spend too much time on this with this group, but this is not a complete taxonomy, but some exemplary harms from automation. So typically, people talk about harms as though something like bias is in and of itself a harm, that somehow their goal is to have an image recognition system which it can't distinguish or has no difference in the probability of its outputs between different categories, even though it probably needs some bias, some pruning of the space of hypotheses of what the sensory inputs it has actually mean. But really, we should be concerned when those differences have some sort of real-world harm that we can connect to. So when we think about bias, I tend to just mentally substitute that with discrimination, which is not a perfect substitution, but is at least helpful. I think for a long time, people have thought of risk in automation harms in terms of loss of autonomy, loss of dignity, right? A lot of literature around dignity and autonomy with respect to bureaucracies that goes back maybe hundreds of years, rich tradition there. And then finally, talk a little bit about safety risks, to human physical safety, which is increasingly a problem for autonomous systems. So as an example of bias and discrimination, people talk about either allocation harms, sort of misallocating opportunities or misallocating risks. So we have examples of scores that misallocate healthcare or misallocate health system resources like organs used for transplant. We also have examples that are well studied of the misallocation of risk, where the justice system will, for example, treat minorities differently than the majority class because of, as Lily was describing this morning, not just kind of the social structural relationships between those classes, but also because those relationships get picked up in the scores and replicated and reinforced and made somehow natural. And that's also true not just for allocation, but for representation. So some of you may be familiar with this example where the Twitter image preview algorithm would essentially always select white faces over black faces as the interesting part of an image that was worth showing in a preview. And partly for this reason and partly for other product-related reasons, Twitter has recently eliminated image cropping from its product. I wanted to move on to some examples of loss of dignity and autonomy because those have come up a lot in the news recently. People might be familiar with the A-level grade scandal from last summer in the UK, where students were given grades on their A-level exams based on the distribution of grades that had been achieved in their school in the past few years, making it very hard to get grades that reflected your actual performance, and in many cases, sort of unnaturally pulling grades down over what students thought they ought to get, and in ways that you might critique as problems with the modeling, but ways in which people felt like their dignity had been affronted by the replacement of grades as achievement on an exam with grades as a prediction from a model based on, say, your class rank at your school. On the left, we have a different protest about autonomy and algorithms that comes from residents, medical residents at Stanford University, who, when the first batch of COVID vaccines was distributed, there was a model, a risk score that was produced, which said who at the hospital was at most risk of death if they got diagnosed with coronavirus disease. And those people were prioritized for administration of the first batch of vaccines. And what that score did by privileging risk of death over risk of exposure, for example, caused a lot of older faculty who were working from home and maybe didn't have any face-to-face patient care obligations to be prioritized over residents who did have those obligations. And so in the first round of scoring, only, I think, 2 residents were selected to receive a dose from the first batch of vaccines. After the protests, there was a review of the system that I believe led to 3 more residents getting prioritized in the first batch. So, protest works, I guess, is the lesson there. Safety, of course, is increasingly a discussion that we have around automation. And obviously, we see risks for putting rule-based systems into the world. The world is very variable. So here we have a situation where you can buy a car, and for a few $1,000s more, you can get the car with full self-driving capability. And if you ask, does that mean that I can just take my hands off the wheel and relax? The company will inform you that that's extraordinarily dangerous. It's sort of humorous and sort of not humorous, right? Like this problem leads to people dying over and over again, right? Many people have died in these accidents. Now, there's some sense that the kind of dream of we're going to have self-driving cars within, N years is somewhat coming apart at the seams. And this problem is not specific to cars. It's not even specific to untrained or inattentive drivers. There was a plane, an Air France plane, A330, that crashed flying from Rio de Janeiro to Paris in 2009, killing everyone on board, flown by trained, experienced pilots, which crashed because the pilots were confused about what the state of the automation was and how they should control the plane and what an appropriate response to the problems they were seeing was, triggered by a fairly simple failure and the pilot's misunderstanding of their relationship to the automation. And then also the fact that the automation did so much of the pilot's work for them meant that they didn't have the opportunity to gain those skills, so that those skills had atrophied since they had been in flight school. And you might say, well, that's just a lack of discipline or a lack of training, but it turns out this affects other systems as well. So on the left, I have a picture of a U.S. Navy ship, the USS John S. McCain, which was struck by a chemical tanker in the Pacific Ocean near Singapore a few years ago. And it was struck because it unexpectedly swerved in front of the chemical tanker. Very hard to stop a ship on a dime. They weigh quite a lot, and they don't slow down or speed up very fast. And the reason that the ship swerved in front of the civilian tanker is that in order to try to handle the tanker contact, the ship had tried to, I can't remember if it was speed up or slow down, but what the operator didn't realize is that they only sped up or slowed down one of the two propellers on the ship, which of course means that the ship is now turning. And once the bridge crew realized that the ship was turning, they were confused again by the automation to figure out which and whether the ship could be brought out of the turn by trying to figure out what the operative control surface mode was on the bridge. And so it's quite a fascinating accident. All of these are quite fascinating accidents. So what I wanted to talk about today was what do we actually do about this? How do we solve this problem? You know, that there are various harms from automation. And so we have a lot of demands that we see from policymakers that we make these automated systems fair or non-discriminatory, compliant with laws, that we make people responsible for their actions, that we make them transparent in various ways. And then we have on the shelf a bunch of technical capabilities. Sometimes people call some of these things definitions of fairness, right, which sound like they are responsive to the policy demand for fair systems, but which don't seem to get much use in practice or don't seem to be very useful in practice, in part because people don't know which ones to deploy in which cases, in part because some of them are mutually exclusive of each other, a problem of which more is made than it probably really means. I asked Katie in the last session about the theory of measurement and how we understand validity and reliability. And there's a whole literature around generalization and robustness and error bounding for tools in data science. I've written a bunch about tooling for traceability and reproducibility of decisions, and lots of work happens around explanation and other debugging mechanisms, ways of saying that a model is correct, whatever correct means. And then you see organizations adopting ethical principles. So I work for the Department of Defense. As I said, I don't speak for the Department of Defense, but I can say that the department has adopted 5 ethical principles that AI systems should be responsible, equitable, traceable, reliable, and governable. I don't want to spend too much time on ethical principles because the problem with ethical principles is that we're not quite sure exactly how to turn them into real behavior of systems. And so I love this sketch, which is a prop from The Good Place, which sort of subverts the idea of the trolley problem. So here, the problem was, how do you kill everyone on both tracks? And so someone has said, you got us all, great work. But regardless of how you understand what the principles are, you have to, in some way, answer a question like, how do we know that the artifacts that we have actually conform to those ethical principles or can be said to uphold them? And a friend of mine who's an actual ethicist, I'm, as I said, not a philosopher, I just play one on TV, described ethics to me as the process of operationalizing values. So he defines ethics as an organization's capacity to reason about how to turn the organization's stated values into real actions. And perhaps people will tell me that's a horrible definition, but I think that's a very clarifying definition, because it says you can quibble with the organization's values, but once you accept what the values are, it's harder to quibble with whether or not the organization is doing a good job operationalizing them as concrete behavior. And of course, if I'm going to talk about operationalizing things in concrete behavior as a computer scientist, I'm obliged by my oath to the field to put up a diagram of software development lifecycle. This is a data science lifecycle for Microsoft. There's no accepted data science lifecycle in industry or in the academic world. And this one is interesting in that all of the parts of the cycle are sort of in negotiation with all the other parts, which doesn't maybe provide as much structuring as it ought to, but probably reflects the essential total lack of process in practical data science work. But we have all of these components that people think are maybe part of the life cycle, or anyway, actions or activities or practices that go on around data science. And a question we might ask is, where in this complicated milieu of things should we situate any of the various interventions that we have? And there are many places you could imagine situating interventions. So if you think about just bias as an example of a thing that people are always talking about wanting to get rid of, sometimes people say bias is a problem of bad data, right? The society is biased, and we went out and we measured society accurately, and then we did all of this stuff which is unbiased, which is not, inherently dependent on race or dependent on some other protected category, or not inherently preferencing one kind of person over another. Or you say we have insufficient data, right? We didn't get as much data about minorities as we wanted to. We didn't get as many poll responses from Trump supporters as we did from non-Trump supporters. And so our view of the world is systematically inaccurate because of that data insufficiency. But you could also turn around and say, well, it's the modeling choices that you make that create these systematic differences. And so you need some way of distinguishing between those cases. Similarly, I put here an interesting point, which is the policies, whether they're government policies or corporate policies, they don't describe how things should work. Typically, they set boundaries for what's acceptable and maybe goals. And then under that set of assumptions, people make decisions about how things should actually work. And so we're still faced with this problem of what does it mean to do AI in a responsible way? And how would we know we've achieved it? And if we could convince ourselves that we were doing the right thing and acting in a kind of moral way around the development of AI artifacts, could we also convince other people that we were doing that? And so in service of that question, there has been a lot of work on what people call AI audits. And audits are either depending on, well, not really depending on, they're probably all of these things at once, that we examine AI systems before they go into operation, so like at the design or development phase, and make sure that they conform to our principles, or we examine them after they go into the field to say, you know, are they holding up to our expectations of how they will perform? In either case, we're going to get some evidence about the system, which might be documentation of how the system was built, maybe the code that actually runs it, maybe operationally some recorded inputs and outputs, either all of them or a sample of them, maybe some outcome measures, right? Like we want to track, you know, how often did the system get the right answer? What does it mean for the system to get the right answer in practice? And then based on that evidence, we're going to make some kind of assessment about whether the system's behaviors are acceptable or unacceptable. Is the gap systematic in some way that we can just fix it as a bug? Is it so bad that we need to pull the plug on this system and shut it down? Is it so bad that we need to, at the development stage, say this system is hopeless, we should never put it into production, or we should, you know, throw away all of this effort and just start over, ask a different question? Auditing is a word that gets applied to this for really historical reasons rather than practical reasons. It comes out of the fact that social scientists do what are called audit studies of discrimination, where you put in kind of similarly situated people. So a famous one is you send the same resume out, but with two different names, like a black sounding name and a white sounding name on the resume, to see how many calls back it gets, where the only difference was the name and the racial valence of the name. And if you talk to accountants, people in the accounting literature, they will tell you that audits are much more about comparing your evidence to reality, sort of verifying that you actually captured what's actually happening, versus assigning some judgment or value to the evidence, which we would often call an assessment. And the goal of all of this is to enable accountability. Here I've sort of shorthanded accountability as responsibility, which is maybe a little bit unfair. But the idea is that we want to make these systems and their behaviors consistent with operative norms. So we have normative questions. And normative questions can be simple to adjudicate, like safety, right? When we talk about the safety risks, not crashing seems like a norm that we can all kind of get behind. But what does it mean for a system to be fair or non-discriminatory, or how much should we privilege that norm against some other norm, like the system treats everyone in under the same process? That's something which is much more contested. So audits, I think, as a computer scientist, we often think, oh, the problem is this model or this piece of software or the rule set in automation. But that object is just one small part of a giant system. So this is a diagram from a book on safety engineering by Nancy Levison that tries to make the argument that safety engineering is a sociotechnical process. There are technical aspects to safety, but also social aspects to safety that come from the social construction of laws, the relationship of culture to the way people act around systems, the human system interface. All of this can be thought of as beyond, just the technical aspects of how the system works. And so often when we hear about audits in systems, we think of them as somehow tied to the specific performance of specific components. in the system, as opposed to kind of an assessment of the control of the system writ large. And so under that theory, I want us to think about audits more as a sociotechnical process. They're not a kind of point assessment in time or like an ongoing assessment of a component's function, but rather they are part of a control structure, a kind of parallel system, or if you like, part of the original system, which can intervene on certain actions and limit or correct certain behaviors, stop certain things from happening. And so in order to make assessments of whether that control structure is working correctly, we need to both understand the behavior of the technical artifact and the kind of surrounding system or the agency implementing that artifact, right? Not only its etiology, but also kind of the goals and interests of that agent in fielding it. I'm often reminded here that computer scientists tend to think of controls as being somehow purely technical objects, where you have some piece of cryptography that tells you this data hasn't been tampered with, and then they say, well, now that we have this thing that tells us that the data we received is the same data that someone sent, therefore no one can tamper with the data. But that's not true. People can still tamper with the data. It's just that when they tamper with it, we now know about it, right? So the technology doesn't enforce the policy. It just identifies violations of the policy. And that's broadly speaking true. It can be harder or easier to sort of circumvent the technology, but ultimately the technology is just kind of a bulldozer pushing the problems around without necessarily reshaping them. So a question that we might ask is, when we talk about control structures, are we trying to stop individualized harms, or are we looking for patterns of harm? That is to say, do we expect the control structure to engage with, let's make sure we hire the right people or never crash the plane or the car or whatever it is? Or is it just the case that we want to lower the rate of crash fatalities as low as possible, kind of driving whatever goodness measure we have in the system toward whatever direction we want it to go? I'm sort of out of time, but I'm going to push through a couple of examples of audits that I think are telling a story here about where we are on the process of understanding what audits are for and how to achieve them. So a problem that gets a lot of attention is the use of data science automation for hiring. So we want to somehow automate the practice of figuring out who's going to be a good fit for a job. So one approach that has kind of gained traction is the idea of having job applicants play psychometric games and then comparing the performance of the applicants to people who are already employed who are thought to be good employees. So you have some features, personality features that you've extracted from people based on these psychometric games. They're not meant to be won or lost. They just expose these personality features. Then you take these features and you use data science, machine learning to build some kind of score that you can use to rank applicants for suitability. And then you can rank people according to these scores, and you can use thresholds to cut off which people you recommend for the job. So maybe you recommend everyone in the top half of the distribution, and you strongly recommend everyone above 70%. One of the systems that I'll mention uses those thresholds as a default, although they're sort of tunable. Natural question is, does this create discrimination risk? Will this replicate discrimination in existing hiring practices because it means that we're hiring people who have personality traits like the personality traits we've hired before? Do we know whether demographic groups, men versus women, blacks versus whites, other minorities, perform differently in the games, or perhaps differentially like abandon the games in the middle? Are there other sources of difference? If you can play these games for like a company that implements these games, for someone who you're applying for a job at, Megacorp, right? Then they say, well, you have to play these games. Does it matter if you play the games on your mobile phone or on a desktop? And that last one, maybe not so much a discrimination question, although penetration rates of desktop computers are wildly different by demographics in most of the world, including the United States, right? We tend to think of everyone has access to a laptop or can go like to a library and work on a desktop computer, but that's not really true. So the Equal Employment Opportunity Commission has promulgated something called the Uniform Guidelines for Employee Screening Procedures, which includes something called the 4/5 rule, which says that if you have a test for employment or promotion, then the demographic group, and it lists a set of demographic qualities that are protected. The demographic with the lowest pass rate of your test must have at least 80% the pass rate of the group with the highest pass rate. So the group that performs the best sort of sets the bar, and then every other group has to do at least 80% as well as that, or the test is not bad, but sort of facially suspect for discrimination. Doesn't mean the test is discriminatory. It just means that the test behavior is sort of facially too dependent on these demographic groups. I should mention that there are many companies that are attempting to work in this space, and large employers use these techniques quite a lot. Even in the DoD, we have recently a report from something called Task Force One Navy about Navy human resources practices that says that there should be a tool created to, I think the verbiage in the report is something like eliminate subjectivity in promotion decisions for officers, which is quite a strong claim, I think, and hopefully the thesis work of one of my master's students will disabuse them of this notion. But in any case, I want to talk about two specific platforms, and these specific platforms because they were audited by computer scientists interested in this kind of discrimination question around the 4/5 rule. So the first platform is called HireVue. HireVue takes video interviews of candidates and then uses, but they stopped using at the same time they released this audit, visual features from the video and linguistic features of a transcript of the video to rank employees for suitability for a job. Around the time they did an audit, they audited a new product which was using these psychometric games to rank people in the way that I described, and that puts them in competition with the other company I'll talk about, and a bunch of other companies. But they were audited, as I mentioned, by a company called Orca. So the O in Orca is for Kathy O'Neill, who is the author of this book, Weapons of Math Destruction. And HireVue contracted with Dr. O'Neill to review or audit their ranking algorithm. But under the contract, the audit did not cover the algorithm itself, not the data, not the code from which it was computed, but just documentation and assertions the company made about how it worked. And mostly it was a stakeholder engagement exercise to figure out what are the ethical risks of using a product in the way that their product was set up. Based on that review of the company's representation of the product, the audit determined that there was no operational risk from using the product in that way. what no operational risk means in a world where you can't actually see what the models are doing or what data they're in fact based on is, I think, a legitimate question that lots of people have asked since this has come out. So by contrast, some academics from Northeastern University audited the products of a different company, Pymetrics, which has for much longer been more focused on the psychometric games structure for job suitability estimation. The details of exactly how that works are fairly well expounded in this paper that was just published about a month ago. Again, the company contracted with these academics. The contract was structured rather than as a kind of a direct engagement with the auditors as a grant to a university, providing an extra layer of oversight. And then what they did is they put their data and their code up in a virtual machine that they then gave the researchers access to and allowed them to train their own models on the data, to do their own review of the source code. But in a sense, their review was limited to just these artifacts that were presented to them without any evidence that those artifacts are in fact the real artifacts that are used in practice, although they confirmed that they believe that based on representations that they saw and other things that they were able to look at and interviews that they performed with practitioners at the company. They also didn't have any ability to cause any of their findings to be remediated. And they went through a fairly in-depth effort to create some notion of distance between them and the company they were auditing. But fundamentally, they still describe it as what they call a cooperative audit, which I think brings me to my last slide, which I'm hoping we can discuss a little bit about ways that we might criticize these audit structures and how we might think of building better audit approaches, and whether that's figuring out the right technical measures to take, whether that's thinking of what is the sociotechnical structure or what is the thing that we need to establish from an audit. And so my PhD student, Commander Ed Jatho in the US Navy, who will, when he finishes, become a permanent military professor at the Naval Academy in Annapolis, Maryland. So that's, good job if you can get it. But he came up with this taxonomy of challenges for audits, which roughly follows this excellent article from Mona Sloan called The Algorithmic Auditing Trap. It's fairly short if you want to seek it out and read it. And he says there are 4 challenges that auditors have for making progress. Those being access. Can the auditors get what they need to make their assessments? Can they be sure that they've done that correctly? Are the auditors independent, or do they have a stake in the outcome? A stake can be a financial stake, right? I hired you to assess my system. Do you therefore have a financial incentive to tell me that my system is fine and doesn't have any problems so that I will hire you again? There have been interesting cases where financial auditors in the private sector have tuned their financial audits to be more favorable to companies so that they can retain that business. Famously, the auditing firm Arthur Andersen failed after giving a passing grade to a large energy company before it went bankrupt, like immediately before it went bankrupt. But independence can also be political, right? It can be, I want to get a promotion, so I'm going to say favorable things about how this works, or I want to advance some policy, so I'm not going to tell this government agency that the way they're doing something is bogus. The third category of problem is kind of audit standards and readiness. What is it that the auditors actually do when they show up? what evidence should they expect to exist, and what measures should they be making of it? You might also class under here questions like, how does the auditee know that they are ready for the audit? So if you think about financial auditing, there is a standard of how financial records should be kept, and also a standard for how records in that standard format should be reviewed by auditors. And so knowing those standards, an accountant can tell you you are ready to undergo an audit. And in other fields, safety engineering, cybersecurity, you have the same thing where you know what the auditors are going through in terms of a checklist, so you can be ready to make sure that you've actually done everything and you're not going to end up with this horrible report that you have to remediate. And then the final category is enforcement. How do you know that any findings from an audit will lead to consequences? Does someone own remediation of those findings? How else might you link findings to consequences? So I'm going to leave it there because I've used too much of my time already, and I'm hopeful that some people have questions, and also if you don't have questions, you can kind of help me unpack some of these ideas, because as I said, I have more questions than answers on this topic. So thanks all for coming.